Good morning, folks. The chuckers are out. I'm hoping it's a good one. When I do my posts and people come along and they rubbish them. Oh, this guy talking rubbish again. This guy doing that. This guy doing this. I always say, be specific. Don't just come along and say, this guy's talking rubbish again, because that doesn't mean anything. You need to be specific. Yesterday, with the Neil deGrasse Tyson and Brian Cox, for me, it was about the bulge. There is no bulge to talk of. There is no bulge, right? Now, I didn't listen. I didn't go to the end of those posts. I don't need to when I look at stuff. I can tell by the first 30 seconds if it's going to be worth listening to. I didn't listen to either of them. I didn't go through to the end. This morning I did. Now, I'm going to be specific with where they are both terribly wrong. I often say so much has been put in place to suggest a round spinning globe. The bulge is one of those things. There is no bulge. There is no bulge. It's not a spinning planet. Now, it doesn't give me any pleasure doing what I'm about to do. This first one's Brian Cox. It's not very long. We listened to most of it yesterday. It doesn't give me any pleasure, but when I don't know that Brian ever has. I know Neil deGrasse. I always think of Terence Howard. That time when Neil deGrasse Tyson shot him down in flames for that stuff. So I don't feel so bad when I do the Neil deGrasse Tyson one, but it gives me no pleasure in doing this with Brian Cox. But we need to listen to it because I am now going to be specific. And if they do decide to do an impromptu talking stick, now they'll have the advantage of knowing exactly what I'm talking about.
Things rotate around in circles, other forces come into play. In this case, a force called the centrifugal force. So that's the force you'd feel if you're hanging onto a roundabout going faster and faster, and you have to hang on tighter and tighter because of the force trying to throw you off. That's the centrifugal force. Now, let's bring the moon back. So now there are two forces at play in this system. There's a gravitational pull, the moon, and pull everything towards it. And there's that centrifugal force trying to throw everything off. But think about the ocean here. That's closer to the moon. And so the moon's gravitational pull wins, and you get a tidal bulge. Now think about this point, on this side of the Earth. That's farther away from the moon. So the centrifugal force wins, throwing the water off, and you get
this bulge. It's non-existent, okay? First of all, this bulge, it's going to be along the equator, okay? Bristol, Ungava, Fundy, and the Cook Inlet. This is where they are, give or take, and that's Whisker. And I've included Los Gallegos in southern Argentina. It's down there, right? Right down there. So they're all fairly accurate when we look at the bulge. How is there a bulge? You've just heard them say there is a bulge. Why are the 5 highest tides on Earth nowhere near the bulge? This is where common sense is important. and the understanding of logic, right? Look, there is no bulge. Then we have the reason for the bulge at the back. This is why we have 2 high tides and 2 low tides every day. There is something really, really, really wrong with this picture. It's not a spinning globe. On Earth, the tides are evenly spaced out everywhere, okay? This moon bulge thing, it's wrong, okay? Now, are they teaching this stuff? Because they were taught it, and they just can't work out that it's wrong? Or are they purposely leading everybody down the wrong path, right? I am slam dunking what I am about to say. I always stand by what I say. Saying that, I was going through my notifications from last night and this morning, and there was one on YouTube, and somebody said, I haven't gone into them, and somebody actually said, at 9:22, you said the moon was the beginning of, I can't remember what the beginning of the word was. So it looks like somebody has found something specific on YouTube that I may have got wrong. So after I've done this and posted this, I will go and have a look, right? Because I did say a while back, be specific, tell me, because I do stand by everything that I say. I'm not making crap up. I use logic and common sense to work things out. And this stuff here, it's not about us. It's about the kids, the children, and they are being just hammered with illogical knowledge, wrong knowledge, and it's just not on. Now, the bulge, the moon is here. We are spinning that way, okay? We're not, but what Brian's just said, we have this bulge here because the moon is on that side. The moon pulls a little bit of earth, whatever, and then we have the centrifugal force. And what has happened, because the moon, its gravitational pull is less on that side, it is the centrifugal force that is creating the bulge at the back. Now, listen, if the centrifugal force was creating a bulge on the rear end, why aren't any of the other lakes and seas moving? I'm being dead set serious here. A bulge because of the centrifugal force. What are we talking all of a sudden now? Cake and eat it too. It's so illogical. If the bulge was happening at the back end, opposite side to where the moon is at, do we not think that the Great Lakes in the US, the Caspian Sea, the Black Sea, if it is centrifugal force creating a bulge at the back, you would think there is no centrifugal force. There is no bulge. Slam dunk. Because if there were a bulge along where they're telling us there is one, why are these places out? The 5 highest tides. If it were 1 or 2, all of them. Why is it that they're all out? Now, what I was saying about the tides, they're evenly spaced out. We get heights. We get heights with the tides. So we've just had the full moon, haven't we? Now, where are we? August. So 1st of August today. Happy birthday, Teresa. We have full moon on the 30th. Where's my glasses? Now, it doesn't just say high and low when it comes to the tides. There's some numbers. And on the 30th of July, which was the other day, what we have here in Australia, in Bundaberg, at 20, so I'm going to go through the day here. So 0313 in the morning, 0313 a.m., right? We had 0.78. That's how high. This is in meters, right? Now, the next high tide after that was 0853. 0853. So this will be, that's low, high, and that was 2:48. Right, so this is AM, and I should put 2:48. So that's the high tide, right? So 0.78 of a meter, low, 2.48 was the high. The next low, I'm doing this because a lot of people might not understand much about the tides if you haven't dabbled with them. So this is now afternoon, coming up to 2:45, and we have 0.6. Now don't forget, this is the full moon. This is the full moon. So we have a 0.78, then the high is 2.48, quite a difference. The next low is lower than the previous low. And then we have the next high, this is going to be the last one, at 22:26. Right, so PM at night. And that was 3.14. So that's higher again. Now the next one on the 31st, 0345. So we're going into the next day, right? I'll just do one more because now it's when they go back down. So 0345 in the morning, we go down to 0.74. Now it's not as low as the last one, right? And the next high tide, this is the last one, at 0345, 0929, 0929 in the morning, and that comes in at 2.53 meters. And this one is, oh, it is. No, it's not. It's not as high. So this was the highest out of that clump, and this was the lowest. And then after this, the highs will probably go to something like 230, and then the next one will be 220, and the highs drop and the lows come up. So there's less of a run. Now this happens everywhere. It's not, there is no bulge. It's not the bulge that is creating the high tides. It's not the moon that is creating the high and low tides. It has nothing to do with the moon. Now, I'm going to say one thing here. If it does have something to do with the moon, and I am saying this because there is one big coincidence in all of this, the new moon position. In the new moon position, what we have is, there's no way of doing this quickly, all right? What we have is the moon and the sun on the same side. This cannot be argued with. This is when we have the highest of the tides. But it isn't gravity. Right? This is the new moon position. This is when we have the highest of the tides. When the sun, the moon, and Earth are in line like this. Right? It isn't gravity, because if it was gravity, when the moon's down here, the moon will be pulling down there, and the sun is pulling that way. It's the neap tide. Now, we're going to listen to Mr. Tyson after this. This is the neap tides. It's when we have the lowest of the tides. So this is the first quarter. So we have the new moon, high, 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 low, 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 then high, and then low, and then the highest, and then low. It goes like that. The only one that works using logic and common sense is the new moon. Because when the moon is over here, they are working against each other. Again, we're going to listen to Mr. Tyson. I am being specific to where they're mistaken. Now, has Brian finished?
Tidal bulge. Now, the Earth just rotates underneath those tides once a day, and that's why you get 2 tides every day. When things...
That's it for... It isn't. It isn't. Because these things here, straight away, cancel all of that out. Because if there were a bulge, and it was frigging centrifugal force and everything, the highest tide would be here. And this is where the Gulf of Mexico is, it's north of, so Gulf of Mexico would be about here. Where else? We've got Mediterranean Sea would be about here. And this is where the low of the low is. So how? How? It is not. Now, I say that they keep on doing this stuff to suggest a spinning planet. The thing is, with the way these tides are and what is happening, we're going to have a look at the flat Earth map after we've listened to Mr. Tyson.
What happens is there is a bulge of water, 2 of them, on opposite sides of the Earth, caused by the sun and the moon. And
Caused by the sun and the moon. The bulge. Well, there isn't. Because the 5 of the highest tides, the 5 highest tides are well out of the bulge zone. So, no, there is no bulge.
Earth turns inside that bulge. So when we say the water rises and falls tidally, what's happening is we are rotating into the bulge and then out of the bulge.
So the bulge is already there.
It's already there.
And all we kind of do is pass through the
Pass
bulge.
through, and the water gets high, and it
Wrong. There is no bulge.
gets low. So we're stuck with language from our own perspective rather than language of what's actually happening.
What is that? We're stuck with language from our own perspective rather than with language with what is happening.
It's simpler that way to say the water goes in and
Yeah.
out. It's simpler to say the sun set rather than Earth rotated such that our angle of view on the stationary sun fell below our local horizon.
Right.
This is,
Yeah, sunset is far more poetic.
you go to the sunset tables.
Yeah.
You know,
This is why I can't listen to this.
so look this up. Let's look at just the Earth and the moon for the moment.
Okay.
Okay.
Which many people think that moon is what causes it.
No, the moon is 2/3 of the tides.
Okay.
Okay. The sun is another. Is 2/3, 3/4. Depends on the distance. The sun has its own tides on the Earth.
Oh, snap.
Wait, in fact, the tides that the moon raises on Earth are the same no matter the phase.
Okay. No matter the phase of the moon, which
Yeah.
there are some people believe that when you have a full moon, what you have is a higher tide because you have a fuller moon.
You do have a higher tide.
Oh, snap.
But the tide that the moon raises on the Earth is basically the same, no matter its phase.
No matter its phase.
What happens at full moon
Uh-huh.
is that the sun's tides add to the moon's tide.
Full moon position. The sun's tides add to the moon's tides, is said. And I am once again saying no. It's illogical. If the moon is pulling there and the sun is pulling here, how on earth, look, wanted that one there, sorry, and this one right here, how on earth is it the higher of the tides? How? Again, we have to apply logic and common sense. The full moon, dark, that side, day, that side. Everybody on this side sees the full moon. Gravitational pull. We have the moon over here in the new moon position, and it's the highest of the tides. We then have the full moon position, and it's not as high, but it is still higher than your average tides. But why? If the moon is pulling on there, it will be slightly pulling on that side. If the sun is pulling on there, it's obviously going to be pulling somewhat on this side. And in that chaos, we have Earth with 6 times the gravitational pull of the moon. And if the moon has a slightly stronger pull than the sun, well, we could easily say that Earth has 7 times or 8 times the pull of the sun. So why are these the second highest tides in the full moon position? It's illogical. It doesn't make any sense, but it gets better. And it doesn't make any sense.
It's precisely.
Oh, snap. We talking about a tide assist from the
The tide
sun?
assists. Because the full moon, you got the moon here,
Right.
Earth, and the sun. Everybody lines up.
That's what it
In
is.
fact, we have a word for that.
Go ahead.
It has the most number of letters when scripted is dip below the line.
Okay.
I know that's a weird record to hold.
Right.
The word is syzygy. So syzygy is when 3 or more objects come into alignment in, cosmically.
Right.
So you have the moon, the Earth. The moon will have the same tide it would at any time,
Right.
but now it lines up with the sun.
Right.
They add together, you get the highest
Highest tide.
tides.
See? The moon comes around, the sun is pulling, the moon comes around, it's on the opposite side, and it somehow assists the sun's pull. But how?
At full moon and new moon. So now I ask you, when would you get the lowest tides?
When the sun is not lined up.
Okay, let me quantify that. So when the sun is at 90 degrees,
Right.
the sun is pulling this
This
way,
way.
and the moon is
Moon's
pulling
pulling
that way.
Now we know we have, let's do the first quarter moon, right? So now we have the moon down here. Pulling down. Like that. Oh, yeah, I reckon so. Yeah. Yeah. Love you, mate. And we have the sun pulling, don't we? Right, pulling that way. Moon pulling down. What happens here? The arrows are there. And listen,
And the two waves
Right.
basically cancel.
Exactly.
They try to cancel one another. So you have the lowest tide. It's called the neap tide.
The two cancel each other. And the arrow disappears. Cancel each other. How? How? How on earth do they cancel each other? Again, it's illogical. It defies logic and common sense. If the sun is pulling that way on the water and the moon is pulling down, cancel each other out. What is that? There's still going to be a pull here, isn't there? And there's still going to be a pull here. So what you would get using common sense and logic is a kind of there, wouldn't you? Don't cancel each other out. They cancel each other out when the moon is here, wouldn't they? When they're opposite each other. Again, the new moon position, when the moon is here, it's the only one that ties in with logic and common sense. The highest of the tides are when the moon and the sun are on the same side. But it's the only one. So there's no pattern. When the moon is above a high tide, it's coincidental. You can track it. You can track the moon and your high tides. It just drops and changes all the way over through the month, right? Now, here's the thing. I think we might be
Neap tide.
See,
Wait. So when people say, I feel the...
It wouldn't be neap tide, the lowest tides. It is the lowest tides when the moon is here. But for crying out loud, there would be an almighty bulge here, and we'd be skinny. Or would they have the centrifugal thing going at an angle? Because it's also wrong. It's just all illogical and wrong.
extra tidal forces from the moon when it's full. It's just bull.
Not ads.
What happens is...
That's it. Thank God. It's all wrong. There is no bulge. So the suggestion that there is, I am saying that the suggestion that there is once again just another push for the spinning globe. For me, that's what it is, because it's non-existent. Centrifugal force. If there is a bulge being created because of centrifugal force as Earth is spinning, would the lakes, the Black Sea, the Caspian Sea, would they not a little bit? Yes. So this is being taught. Newton. It's Newton. It's wrong. It has no gravitational pull. Now, for a while, when I had to dig myself because I needed to know what the go was with the tides. I had to know because I had always believed the moon was affecting the water. So when I started to look at this flat earth thing, I was going to go nowhere until I worked the moon out and the water and the tides. And I did. And I came to the conclusion that it has nothing to do with the tides. And it doesn't. If it does, it is something to do with the new moon position, but not gravity. It's something else. The only thing in all of it, moon, sun, is when sun, moon, earth, we have the highest tides. Can't be argued with. But after that, as soon as the moon moves, nothing means anything. There's no pattern. It's all wrong, illogical. So, where does the moon go for that 2 days? Like when it's new, we don't see it. Look, I'm just talking out loud. Now, so what is moving the tides is the question. I've slam dunked this. Something else is displacing that water. Something else is displacing the water on Earth. Bristol Channel. No, sorry. Bristol Channel. There. The Bay of Fundy is that one there. Ungava Bay is up there. The Cook Inlet is up there. Los Gallegos, Argentina, is down there. Now, there are your 5 highest tides. All right? Those are your 5 highest tides. Now, for those 5 high tides on the globe, they don't make any sense whatsoever. They don't. They just don't. But on the flat Earth, something else is displacing the water. Something else is displacing the water. Where do we go from here? The North Sea. So what do we have here? Where are we? The North Atlantic. Right? South Atlantic's down here. We have the Pacific. North Pacific, don't we? Pacific down here, Southern Pacific Ocean. We have the Indian Ocean. Indian Ocean here. We have the North Sea, which is up this side, isn't it? The UK and all this here. The rogue waves, the amount of boats that go missing, the choppy water, the swells, 30-meter waves come out of nowhere. The maelstrom in Norway, the strongest currents on Earth are here, next to Norway, the maelstrom. We have the Bering Sea, all that stuff's here, isn't it? It's not the USSR side, is it? No, I'm sure it's this side. It's all along here, isn't it? Greenland, all of the north, all of this. It's Alaska, it's all chop, isn't it? And it's all the center. Tides are coming up. The highest. Cook Inlet, Ungava, Fundy, Bristol. Tides, something's coming up. Don't forget, when it drops, it goes back the same way it came out. That is not a round and round motion like the moon. Something is displacing the water. It's stopping for up to an hour, and then it's dropping back, and it goes back the same way it came. The globe spinning. The bulge, they pushed the bulge. Why? Why have they pushed the bulge? Why have X amount of litres of water that have been pumped and displaced on Earth 2 decades, between 1990 and 2010 or something, it's caused Earth to tilt, hasn't it? Suggesting that it's a spinning planet. These things are everywhere. The bulge is a lie. It's a massive one. because it has to do with the gravitational pull from the moon. And it's non-existent. It's non-existent. If it were, those high tides would all be along near the Gulf of Mexico and the Mediterranean Sea. But it doesn't work like that. The tides, doesn't matter where you go, like I showed the ones in Bundy, between 0.6 of a meter and 3.2. In, I don't know, the Bay of Fundy, you've got like 60 feet at the top. That happens, they get their highest tide, but whole of Earth gets their highest tides at the same time, but proportionally the same. It's not more in one section than it is in the other. It rises the same everywhere and drops the same everywhere. It's uniform. There is no chaos of the moon spinning around a spinning planet. Something else is displacing the water. Slam dunk. It is not the moon. Slam dunk. Not with gravity anyway. Now, there is one other thing. I'm just going to throw it in. Let me just pause this for a second. Oh, I hope this one's a wrap as well. I'll be 2 seconds. And it's back again, isn't it? Right. Now let's go over to this board. The tide. When the tide's coming, right, what happens, you could break this down. You could break the incoming water, doesn't matter where you are, into 12ths, 12 sections. So we're going to do it with the 6 hours, okay? So we have, and then another. So this one here is halfway in, right? So we have the bottom of the tide, and when it comes up, we have, these would be split, it's into 12. So you have the bottom one, it's 1/12 of the height in the first hour, right? There's 12 twelfths, and there's 2 twelfths in each hour. 6 times 2 is 12. 1/12. In the second one, it is it 2 twelfths? I think it's a 12th. Another 12th, right? And then 2 twelfths here and 2 there. No, sorry. It's been a while since I've done this. Look, let's go for it comes in slowly here. The first hour, right? The first hour, it's slow. The second hour, that's right. 1/12 is the first hour. 2 twelfths is how much of the height happens incoming in the second hour. The third hour, 3 twelfths coming. The fourth hour, another 3 twelfths. So this right here, this period here, the middle of the tide coming in, comes in for 6 hours. Hours 3 and 4 is when it rushes hard, right? And then when it comes up to the 5th hour, it slowly backs off. And in that last hour, you get that one final 12th coming. And then you get the slack period. The pattern, again, something that I worked out by banging my head against the wall, trying to work out what was going on. This is what the pattern looks like. So you have a ball, a sphere. You go into the water, and there is little volume at the bottom. But as you start going down, if I go down at the same speed, when we get to that part there, the middle bit, there's more water displaced, see? And then it gets to the top, slows right down, poof. And when it drops, it's the same. If it was a sphere, it comes out, there's a little bit, so it's not too much of a drop, and then it gets to the big volume part, and there is a bigger, faster drop, and then that is rough. That is the pattern. That is the pattern. That could, look, I'm not saying that it's the moon dunking itself into the water, but the pattern that we have, that 1/12, 2/12, 3/12, 3/12, 2/12, the last 12th. That's the kind of speed we're looking at. It is. It's almost like something is breathing. Up. Down. That is the pattern. The tide's coming in and out. It's uniform. It's not chaos. It's not the moon. Right, folks, I stand with everything I said. I don't get much pleasure out of doing that, but they do it, don't they? Oh, he's wrong, and they take the Mickey Mouse. If you're wrong, you're wrong. Still stands, but with a stick for the talking. But now, at least they have specifics where they're wrong. If they want to battle it out, then fine. But there is no bulge. The high tides would not be where they are. All right, folks. I was a little bit today. 42. Look, I'll be back later.